cool, but the problem with these things is you can't really get much propane out of them, and I'm going to need a lot to run this thing. And when I first set this up, it only made like a 3-inch flame, single flame, and I'm going to have a round burner with a bunch of nozzles, so I'm going to need a ton of propane out of this thing. It'll drain it quickly, but it'll be cool. So I did the only thing that made sense to me, and that is take the needle valve out of this thing and then send a 1/16 drill bit right down through the center of it. I'm going to go ahead and assume that in most circles, that's probably frowned upon. I don't really think you're supposed to do that. But we're going to see what happens here. That's a whole lot more. I think that's probably good. And I think this falls under a if you know the rules, you can break them type situation. Maybe. I don't know. Maybe we're going to burn the garage down. We're going to see what happens. What is up, everybody? Welcome back to RanWhenParked. Today I have a little bit of a offbeat or obscure episode going on for you guys, and that is because we are not going to work on the array of car projects that I have to work on. We're not going to work on the Land Cruiser that's behind me. We are not going to work on the Altima that's over there. We are not going to work on my RX-7 FD, which is in storage elsewhere. We are not going to work on my 51 Jeep, and we are not going to work on the 63 Ford, because we are going to procrastinate on all of those things and build a home-built jet turbine. I know what you're thinking. There's a lot of videos on YouTube where people have built home-built turbines. They start with a turbocharger. They hack together a big external combustion chamber that turns it into this like behemoth of an assembly. It's kind of weird. And they run. And usually they don't have an oiling system, and they run them on propane. And they run right up until they overheat and consume themselves, and then that's the end of the show. That is not what we're going to do here today. So I have been involved in a project like that. I have built one with an external combustor, and they're pretty cool, and they do run, and like that's all neat and stuff. But I've always wanted to build one that was like really contained and has what's called an annular combustor, which I'll show you what that means later. So it's really compact. It doesn't have any external components or anything, and it's really more like what you would see in like a commercial jet engine as they sell them, like what's on a plane or on a ground-based turbine, a variety of different applications. And I have a plan to do that, and I think it's going to work pretty well. I am going to start with a turbocharger. That way I get a good compressor, a centrifugal compressor and an axial turbine. I am going to eliminate the exhaust housing altogether and build my own housing. This is going to be pretty interesting because I don't know of an example of someone else on YouTube or elsewhere doing something like this and making a completely enclosed annular combustor jet engine. I doubt it's the first. People have done everything, but I don't know of another example. I have seen where people mess with the little RC turbines, and those are really cool, but that's all pre-built stuff. So this is going to be really interesting. We're going to be learning a little bit together on this one. So let's get underway and continue procrastinating on the car projects. Okay, so home-built or lab-built jet turbine. Take one. So what we start with here is a turbocharger. Everyone starts with a turbocharger, or most people. And the reason why is because you get a nice bearing housing, and you get a nice impeller, and you get a nice axial turbine. And, those are the basic components. And most importantly, it's all balanced. Because if you spin this thing up to 100,000 RPM, you're going to wish it was. If it wasn't, as it implodes like a hand grenade in your face. So this is a Switzer. I think it's a 58 millimeter. Looks old, but it's actually brand new, just rebuilt by the factory. And I had two of these matching that a friend had sourced for me because I was going to use them as a twin turbo setup on my RX-7 with a 5.3 liter LS engine. However, these days my goals and aspirations for that car have kind of changed. It now has a 78 millimeter single turbo setup on it, and the 58s would have been a little small. So even if I went twins, I'd probably do like twin, 62 ball bearings or something. Bottom line, this Switzer was sitting around. So I started messing with this thing the other day, and the big breakthrough for me, not a breakthrough, really just a change of thought, was, these things have an outlet on them, and then most people, when they mess with these things, they do like a big external combustion chamber. And the way that works is, this doesn't have an exhaust housing on it. It comes out of the outlet into the combustion chamber. You have your flame tube in there. You usually burn propane, and then the exhaust goes into the exhaust housing. It turns into this big, you know, massive assembly just for a tiny little compressor. And the whole thing's just kind of silly, although I will admit, like, they'll run like that, and you did make a turbine. That's pretty cool. Making it enclosed is an entirely different deal. So my first challenge was finding a way to make this a factory exhaust housing, which is a key component because it fits really tight, so it has excellent air scavenging capability inside there, actually blow out the back. And I'll show you guys how I'm going to do that eventually. However, the start was to cut off the outlet for the compressor and to, you know, completely cover it. So what I've wound up with, let me take this apart real quick, is a compressor housing that goes to nowhere. Right? So a lot of machining down in there, which is why I wanted to use it. However, it leads to nowhere right now. It would just create a massive high pressure area right in here, which means I have to bleed that air backwards through the backing plate. And I have to build a combustion chamber immediately behind it surrounding this center bearing housing. Easy enough. And actually, in normal situation, that would be a relatively difficult thing to do. I've thought about it for years, what an optimal way to do that would be. And just recently on my way home from work, I realized not only is there a relatively simple way to do this, I also have all the parts. So. All right, so now that you guys understand how I got this far, what are the next steps? Well, we have to build the combustion chamber. So we have this thing right here. I explained to you guys how all this came together, right? The next thing is the combustion chamber. And now normally, like I mentioned in the first place, what you would do is you would have like a separate combustion chamber outside of this thing that just hooks onto both ends, the compressor and the turbine, and that's how you do it. We're going to make an annular combustion chamber here. And the way we're going to do that is first by protecting this center housing, right? So I have absolutely no doubt if I just built a combustion chamber in here, I could run it for some period of time without this, you know, center housing getting overheated, but eventually it will get overheated, right? So I do want to protect it in some way, especially this back edge. I think I'm going to get a lot of heat concentration right on this back edge, and I'll probably melt it eventually. Well, maybe not melt it, but I'll overheat it and warp it, and it'll be problems. So I'm going to take this, and I'm going to put it right over this thing, okay? So it's going to go something like that. I have to trim it around the oil feed in return, which I'm going to be modifying. You'll see more on that later. But that is going to protect this center section and be the inside of my combustor, okay? And then after we do that, we need our flame tube, right? So our flame tube is going to be this. So everything between the inner liner and here is going to be where the flame resides, right? That's going to be full of very, very intense propane-fueled under pressure flame. Past that, we are going to need our pressure area. So that is going to be the outside case, which is this piece. Okay, so that is 7-inch pipe. So we are going to have our fuel coming in the back here. We are going to have our air coming through this outside edge, pressurizing the area between this case and this case. It is going to go through a variety of holes in this case, which is all calculated out where those holes are, how big they are, etc. It is going to feed the flame, which is going to drive this turbine. So all these fit, but I do need to shorten them and get them to the right height. However, first things first, I want to build the burner. And the burner is going to go around in a circle right here and stay between this diameter and this diameter. Now that is going to be a tough thing to do with the oil passages in there, which means we're going to have to trim them down, make some modifications here. But that's what we're going to do next. So first things first, I'm going to roll my burner into the right diameter, and I'm going to show you guys how we do that, and then we're going to light it off and see how much fuel flow we actually get and whether or not I think we're going to be able to drive this thing, or we're going to have to modify our nozzle sizes, etc. So let's get going on that. So we have our bung MIG welded in there now. Looks good, everything's fine. I also wire wheeled all the paint off here because I'm either gonna have to weld on it, so you know I gotta get a good ground and a good connection, or it's gonna burn off anyway. So Next thing, we need to put our inner combustor on. So that is going to be this very thick wall, 3.5-inch pipe. And I already marked it where I need to cut it so it can slide down over the inlet and outlet for the oil and sit right up against this backing plate. I did the same for the drain, so I'm just gonna hack those out of there really quick, and then we'll see how this thing fits up. So our inner combustion chamber is now all welded up. The only problem with it now is that it's a little bit too long. Obviously, it extends past the outside of the bearing housing. I really want it to be flush with the bearing housing. So I was going to chuck it up with the lathe, but then I realized that my chuck will not open up enough to get the OD on this backing plate. So we are going to measure this up. I'm just going to cut it off with a cutoff wheel. And then we're probably just going to tack this around the edge. I really don't see a reason to actually like seam weld this thing all the way around. I really don't want to do too much welding on the actual backing plate because I don't want to overheat the bearings. Although, even with all these modifications, I could still completely rebuild this bearing housing, which is kind of cool. So it's very, very hot still. So yeah, I'm just going to cut that off real quick. And then we're going to start sizing up our actual burner tube that goes around this thing, which is exciting. And that's where I wanted to get today. So let's chop it off real quick. There you have it, guys. Our combustor, burner, ejection system, nozzles, whatever you want to call it, are now installed. It's a little bit off center from the oil filter, which is a little annoying, but you know, you can't win them all. So it's tack welded down. It doesn't want to move. And then I even took the flame tube, notched it out, and it fits on top of it just like that. Actually, it's a little off center. It's more like that. I'm gonna have to drill another hole in this to get the oil feed in, but the nut fits, the feed line will fit, and everything's gonna work beautifully. I did tack weld it to the backing plate, so the fuel ring is not going to move anymore. It actually turned out beautiful. It's a little bit of a pain in the butt, but you know, it always is something. So next thing we're going to do is we're going to take this flame tube. I'm going to cut it down to length, and then I'm going to show you guys the pattern that's going to go in this thing to get pressurized air into the combustor and make this thing go. So let's get moving, cutting this thing down, drilling all the holes, and we'll move forward. Almost there. So there it is, trimmed down. It's a rough cut, but I got to straighten it out. I'm also going to sandblast it and clean it all up and stuff, but it fits back in there. I'm not going to press it down because it's really tight, but it's perfectly level with the bearing housing. The next step is going to be we need to do the outside of our combustor, which is going to be made out of this. This is convenient because it's already necked down. So what I will wind up with is an assembly like that. So on the inside is the flame tube, on the outside is the pressure. The pressure will go through the flame tube, feed the combustion with high pressure oxygen. That is how you get an extraordinarily, I guess, violent combustion in there would be a good word. So we have to cut this one down next. That's going to be really easy. I'm just going to mark it off really quick so it's the same height. And then we'll chop it off. We'll lay it on there and see where we're at. And there we go. So we have our drain hole in there. It fits extremely, extremely tight against this thing. And in fact, it doesn't even fit just yet. You kind of have to thread it in. And I got really lucky here because this portion of it is turned so high on the NPT tap that I can actually turn this thing down in the lathe quite a bit. Not the top, but you know, the non-threaded part and part of this threaded part. And I can get that thing until it's like a perfect fit right inside there. And I also did the other side too, and I have the exact same situation going on over there also, where the threads fit in no problem, but then the shaft is a little tight, non-threaded portion. So I'm just going to chuck that up in the lathe and turn it down a little bit. And then once I've done that, all I need is clearance holes on this portion of it, because that's where the pressurized air is going to be going in anyway. So this is the only thing that actually has to be sealed. So really happy with that. It's pretty much perfect. So we can now move on from there and start talking about drilling this thing out and welding the combustor together. So yeah. All right, guys. So real quickly, let's do a little bit of math. So working on our flame tube here. Here's a drawing of the flame tube, right? So the way you want to do this is you have 3 sets of holes. You have your primary, your secondary, and your tertiary. The primary and the secondary are for complete burn. The tertiary is essentially for air bypass around to cool the charge before it gets to the turbine. Cooler charge equals denser charge equals, more engagement, we'll say, on the turbine wheel. The totality of these holes, you want to equal roughly the inlet on the turbo, and that is going to be the smaller diameter on the compressor wheel, which is called the inducer. In the case of this turbo, we have a 58 millimeter inducer, which is 2.28 inches in diameter. So you can calculate all the size of these holes relatively simple. I did all the math here, and I'll explain why in a second, but there are calculators online to help you calculate all this stuff. So my combustor is 3.25 inches in total length. I decided to put my primary holes just above the burner. So 1 inch and 1 3/4 of an inch, or actually that is to say 5/8 of an inch and 1 inch, 2 rows. The secondary holes are 1 3/4 of an inch, and the tertiary holes are 2 3/4 of an inch. And then I have the surface area of each of those holes. So I need a total area of 1.22 inches of hole for the primaries, 0.82 inches of hole for the secondaries, and 2 inches of hole for the tertiaries. The tertiaries are obviously the biggest for the air bleed. And you can see the direction the air is going, the compressor down at the bottom at the primaries, and then out to the turbine after the tertiaries. So that leaves me with 25 holes at 1/4 inch diameter, which leaves me with a spacing of 1.3 and 1.3 inches. I'm going to do 2 rows for the primaries. So it's going to be 12 holes and then 12 holes in 2 rows, 1.3 inches apart, all the way around the circumference of my 5-inch tube, which is 15.7 inches in circumference. The secondary holes, there will be 16 at 1/4 inch diameter. That's going to be 1 row. And then the tertiary holes are 19 at 3/8 diameter, and that is going to be 1 row also. So there's the math. Again, I'm missing some stuff here, but there's calculators online that can help you with this. So I already laid all that out. So here is our flame tube. Each one of these represents a hole. We have our primaries around the bottom, we have our secondary in the middle, we have our tertiary on top, and I actually skipped a couple holes in the bottom in places where I know I'm going to get a lot of air bleed through, like the clearance holes that are equal or greater to the actual surface area of one of those holes. Now, the reason why I did this math myself is because this is a very short combustor. Common knowledge in the world of people who are building jet engines out of turbos is that this thing should be like a foot long. And I agree with that, but most of those people are building the type of external combustion chamber turbo that I did not want to build. I wanted to build an annular combustion turbo, and because of the limitations of the size of the bearing housing, this is essentially what you have to do. I mean, you only have the space between the compressor and the turbine, right? That's all you have to work with. So I pretty much used every little bit of that I possibly could. I do have some preliminary designs in my head how I can extend this thing out, but for now, we're going to go with it, and we're going to see how it runs. I just figured I would mention that before anyone chimes in the comments and says, well, this is never going to work, or it's horrendously inefficient. I agree, but also if I wanted a very efficient turbo, I would go on eBay and buy a used Solar turbo. That's not what this is about. This is about trying to build an annular combustion turbine in the garage. So let's get to drilling this thing, and we can wrap up the combustion chamber and move on to ignition. Okay, guys, so really quick, I just want to talk about the design here. So I've mentioned multiple times that I'm going to build one of these with an annular burner, which I don't see too many examples of, especially on YouTube. So I want to explain to you what that means. So back in the 40s, when all of this was coming together, there were a variety of different designs for jet engines. Most of them revolved around separate combustion chambers. So here I have one of the original patents. This was by Frank Whittle, and you can see here the center section, just like I have, and then multiple combustion chambers around the edge. They're all round. It's pretty easy to, develop a round combustion chamber as far as how much fuel, how much air. The calculations are relatively simple. And they had 8 of them in this example. Some of them had more, some had less. Nonetheless, this is how it was developed, was with multiple combustion chambers around the edge. Later on, what happened was they would take maybe these 4 and they would connect them and make, a round shaped, like moon shaped combustion chamber, and they would have one on each side. That was called a semi-annular combustion chamber. Eventually, the design evolved to the point where it was one combustion chamber all the way around, and it was round, just like I'm showing you on my example here. So all of these would be connected all the way around. You would have a fuel rail that is perfectly round, and that entire area would be filled with the combustion of the fuel and pressurized air. So that's what I mean by an annular combustion chamber, and that's what I mean by I don't really see too many examples on YouTube, at least, of people making these from scratch that are fully annular. So I wanted to explain that, and if you're wondering, yes, I am nerdy enough that hanging on my wall, I have one of the original patents for the jet engine. It is what it is. Okay, so there's our flame tube, all done. Lots of holes, came out perfectly fine. I deburred the whole thing and stuff, so all good. Next we have to make the flange, but before that I want to show you guys ignition system. So I thought about this for a little while, and obviously I could make one with like an automotive coil, but they're big and I want this thing to be pretty well enclosed. I'm going to make a stand for it that's going to hold like a fuel tank and a battery and a bunch of wiring and the oiling system, and I wanted the ignition system to be relatively small. And then it hit me. Those that watch the channel know that I do a lot of stuff with LS engines, GM Gen 3 and 4 V8s. My Land Cruiser right there has one in it. That's a 4.8 liter. My RX-7, which is stored somewhere else, has a turbocharged aluminum Gen 4 5.3 liter. And therefore, I have a lot of LS parts hanging around and multiple sets of coils. So I just grabbed a coil and I looked up the wiring diagram, and it's relatively simple. So here you have it. I mean, it's 4 wires, 2 of them are grounds. Take your battery, hook up your ground, right? And then all you have to do is put your spark plug on there, which, would be, in this case, grounded through the case of the engine and stuff. And then you have your feed wire, you touch that to the positive, you get a spark. So it's relatively simple. Let me just set up the camera and show you real quick. Okay, so now I have my 1/8 inch thick steel plate, and I did trace, I don't know how well you're going to see it, I guess you can see it, a 7-inch diameter and a 5-inch diameter. It's traced out in pencil in there, and those 2 diameters are because the outer diameter across these, not the bolt holes, but the bosses on the compressor cover is 7 inches. So I'm going to go right across the outside of those, and that gives me room to put the bolts in. And then this is the 5-inch, so that goes on the inside. So what you have is that's going to be welded to the plate. The inside will be cut out. That will be welded to the plate, and then you can bolt it in all the way around the edge. So that's what we're going to do. That'll bolt onto there, and that means when I go to disassemble this thing, you take those bolts out, you take it off, and you would still have this right in the inside. Now, on the other hand, this is going to be held down by the flange also, because it's going to be on this surface. So therefore, once you take those bolts out of the edge, the whole combustor comes off, the whole bearing section comes off, and everything's disassembled. It's real simple. So what I'm probably going to do is hack the inside out relatively accurately, as round as I possibly can, and then I'll rough out the outside, and then I'll just chuck this up in the lathe and turn the outside, because since that's going to be exposed, I'm going to want it to be really, really nice. So we'll start hacking. And this is probably turning into a long video, so I'm just going to show it to you complete. All right, guys. So unfortunately, I do have to split this into 2 videos. I really wanted to make it one, but it's just too long. While editing it, it got to like 45, 50 minutes, which is just too much. So I'm going to cut it off right here. We're making good progress though, and the next video is gonna follow this one immediately. So, because I'm basically done with this project. So for now, don't forget to like, comment, subscribe. Definitely tell me what you're thinking below. If you know of any other videos where people have built similar engines, like, you know, enclosed engines like this, definitely link them. I wanna see those. And stick with me on this one, because this thing turns out pretty awesome and you're definitely gonna wanna see it. Until then, I'll see you guys next time on RanWhenParked.